Welcome to the CanJS video tutorial. This video walks you through the documentation and covers building a basic to-do app. With a little bit of JavaScript knowledge, you'll be ready to build something amazing with can.JS. So let's start by peeking inside CanJS's core. can.Construct is used to create inheritable constructor functions. can.Observe provides the observable pattern. It's used to listen to changes in objects with key value binding. can.Model connects can.Observes to persistent data, and although it can work with any data source, it makes JSON REST interfaces extra easy. can.View is used to load and cache JavaScript templates. It is designed to be used with any template language. Embedded.js is CanJS's default templating language. It's a lightweight and expressive templating language that automatically updates itself when data changes. can.Control is used to create memory-safe widgets and controls with declarative event binding. can.Route is used for back button and bookmarking support. This section covers how to get CanJS and set it up for a simple app. We'll be building a very basic to-do app that lets you edit and destroy to-dos and use the forward and back button to toggle between editing the to-dos. CanJS runs from several libraries, including jQuery, Zepto, Dojo, MooTools, and YUI. This demo uses jQuery for DOM manipulation. So I'll download can.jQuery.js and jQuery to my public folder. You can follow along with other libraries, just change the jQuery specific parts. I'll create a to-dos folder, and within it put a to-dos HTML and a to-dos JS. Within to-dos HTML, I've added some boilerplate HTML, and I'll add script tags to load jQuery, can.js, and to-dos JS. Finally, let's open to-dos HTML, fire up Chrome's developer tools, and begin development with can.js. We'll begin by learning about can.Construct. can.Construct is used to create JavaScript constructor functions. Similar to classes in other languages, constructor functions are used to create objects with shared properties. can.Construct makes these constructor functions easily inheritable. To create a constructor function of your own, call can.Construct with static and prototype properties of your new constructor. Static properties are optional and added directly to the constructor function. Prototype properties are available on instances of the constructor function. To make something inherit from to-do, follow the same pattern as inheriting with can.Construct. Initialization code goes into constructor function's init method. When new is used with a constructor function, it creates a new object which we refer to as an instance of the constructor function, and it calls the init method with the arguments passed to the constructor function. can.Observe provides the observable pattern for JavaScript objects. It's used by both model and route. After creating an observe, you can read, set, and remove property values on objects. But it wouldn't be an observable unless it let you listen for property changes. It even works with nested data and arrays. Let's check out can.Observe's functionality in more detail, starting with its attr method, which is used to get and set a property or properties on an observe. Calling attr with a property name returns the property value. Passing in a property name and value updates the property value and will notify any listeners. Simply calling attr returns the observe's data as a simple JavaScript object. Passing attr an object merges those values into the observe. Notice how offset is still 100. Finally, by calling attr with an object of properties and true, this means it will remove any values in the observe that are not present in the passed-in object. Notice how offset and count are missing. Remove attr removes a property by name from an observe. This is similar to using the delete keyword to remove a property. Bind listens to changes on an observe. You can listen to any change on an observe by binding to the change event. A change event handler gets called back with the attribute that was changed, how it was changed, the new property value on the observe, and the old property value. The how argument can be either add, set, or remove, depending on the change. An add event happens when a property is added for the first time. A set event happens when an existing property changes its value. A remove event happens when the property is removed. You can also bind to a specific attribute change. Attribute event handlers get called back with the new and old property values of the observe. Unbind stops listening to an event. The same event handler function that was passed to bind must be passed to unbind. Notice how I declare count handler, pass it to bind, and then I trigger the event handler by changing the count. To remove the event handler, I call unbind with a reference to count handler. Now, when I change the count, we don't see the count has changed. Later we'll see how, by using can control to listen to events, you shouldn't have to worry about unbinding. Each iterates through every property on an observe, calling the handler with each property value and name. CanJS lets you observe arrays through can.Observe_List. Can.Observe_List inherits from can.Observe, letting you get and set properties through attr. But it adds list-specific methods such as indexOf, pop, push, shift, unshift, splice. Similar to observe, you can bind to any change with the change event, but list also lets you bind to the add, remove, and set events. Add gets called when an item or items are added to the list at a specified index. Remove events get called when an item or items are removed from the list at a specified index. Set gets called when a value at a particular index changes. There's also a length event that gets called anytime the list's length is changed by insertion or removal. So, if we remove the last item in the list, remove and length event handlers are called. If we add an item to the start of the list, add and length event handlers are called. Model is an observe that can be created, retrieved, updated, and destroyed from some form of persistent storage. Let's take a quick look at how it works. First, create a model constructor function and specify how to get, create, update, and delete the persistent data. Then, create a new to-do instance and save it to your server. Notice how it posted a request to the to-do service, and the server gave us back an ID property. To get all to-dos, call findAll. Here I'll log each retrieved to-do's name. Notice how findAll made a GET request to our to-do service. To get an individual to-do, call findOne. Notice how it makes a request to to-do/4. To read a model's data, you can just use the attr method like observe, and you can also update properties with attr. To update the data on the server, call save again. Finally, to delete a model instance, call destroy on it. Now we can finally start adding code to our to-dos app. Open todos.js and create the to-do model like the following. Notice the special findAll, findOne, create, update, and destroy methods. These are model's service methods. They are used to describe how to retrieve, create, update, and destroy model instances in the persistent data source, in this case, a JSON REST interface. But before we get too deep into the service methods, let's review how to create a model instance. Make sure you save todos.js, refresh your browser, and open up the console. Similar to observe, to create a local model instance, simply use new and pass it an object of properties and values. And, just like observe, you can use attr to get and set properties. To talk to the server, a model implements the static findAll, findOne, create, update, and destroy methods. By filling these out, you are able to call findAll and findOne on the model to retrieve model instances, and save and destroy on a model instance to create, update, or destroy it. As we don't have a server, we'll be using can.Fixture to simulate one. So I'll download can.Fixture.js and add it to the list of script tags. Now we're ready to learn how to connect a model to service data in detail. Let's start with the findAll method. FindAll is used to get multiple instances from the server and calls a success handler with those instances. If the request fails, it calls back the error handler with data describing the error. FindAll also returns a deferred. A deferred is similar to a promise. It is an object that will have a value some point in the future. They make certain patterns like parallel loading much easier, but that is a video for another day. You implement findAll with either a function, an object, or a string. As we are connecting to a simulated JSON REST interface, the easiest way to implement findAll is with a string. This will make a GET request to to-dos and expect it to return a JSON array of instance data. We can simulate this with the following fixture. After refreshing, we can try findAll in the console. findOne retrieves a single model instance and works very similar to findAll. As findOne is implemented with a string, it makes a GET request to to's ID, where ID is the param's ID value. You'll notice that model supports templated URLs. The request to to's ID is expected to return JSON data for the model instance. We can simulate that with a fixture, but I'm going to change the findAll fixture and the findOne fixture to use the same data source. can.Fixture provides the request data. I'll use the ID to return the right data from the to-dos array. After refreshing, you can use findOne. Save creates or updates a model instance depending if the instance has already been created on the server. If the instance hasn't been created, it calls the create service method. Otherwise, it calls the updated service method. The create service method is implemented as a string. It will post the to-do instance's attributes to the to-dos service. The server should respond with an object that contains the new object's ID and any other properties the server added to the instance. We can simulate this with a fixture. First, we'll use the to-dos array length to generate an ID for the instance. Next, we'll add the instance data with the ID to the to-dos array. Finally, we return an object that contains the ID. Now we can create a new instance in the console. And save it to the server. Notice how the to-do now has an ID property. If save is called on a model instance with an ID, the update service method is called with the to-do's data and ID. The update service method is implemented as a string. This makes a put request to to-do's ID and should return any additional attributes the server modified. We'll simulate this with a fixture. The fixture updates the to-do's array with the request data. Now we can update a to-do with the mock service. Calling destroy on a model instance deletes the record on the server by calling the destroy service method. The destroy service method is implemented here with a string. This makes a delete request to to-do's ID. The server is expected to return a successful response if the record is destroyed. We can simulate that with a fixture. In this fixture, we could remove the to-do instance's data from the to-do's array and would have to update the other fixtures to work with IDs that don't map to array indexes. But for this demo, it's not necessary. Now we can call destroy on to-do instances. Bind listens to changes in a model instance's attributes in the same way as observes bind. For example, I can listen to when a to-do's name changes. In addition to observes events, Model also supports 3 new events: created, updated, and destroyed. You can listen to these events on a model instance or on the model constructor function. Event handlers bound to the model constructor function get triggered when any instance is created, updated, or destroyed. Let's see how this works. I'll create a static event handler that reports what event happened and the to-do that it happened on. We'll bind this to the to-do constructor function's created, updated, and destroyed event. And I'll create an instance report event handler that reports the events on a specific to-do instance. Now that I've hooked up all these event handlers, I'll create a to-do, update it, and destroy it. Notice how static report and instance report are called each time. But if I create another to-do, only static report is called. Model list is an observed list that contains model instances. When a model instance is destroyed, it will automatically be removed from the model list. Model lists are provided by findAll. In this example, I will get a to-do's model list from findAll. I'll listen to when a to-do is removed from the list. And destroy the first to-do. Notice how the to-do is no longer in the list. This is really useful for live binding with lists, as we'll see shortly. View is used to load, cache, and render templates into document fragments. It works with many templating languages, but we'll show its use with CanJS's default, embedded.js. View loads templates from a URL or script tag, rendering them with data, and returns a document fragment that can be easily inserted into the page. Let's show the list of to-dos on the server in our to-dos HTML page. First, I'll add a to-dos element to to-dos HTML. Next, I'll create a template embedded in a script tag that goes through a list of to-dos and writes their names. I'll add an ID and type to the script tag so can.View can reference this template and know which template engine to use. In to-dos.js, which I've rearranged slightly to make it more readable, I'll find all to-dos and then render them with EJS into a document fragment and add the result to the to-dos element. Let's see the result. To load this template as an external file, I can create to-dos EJS with the same template and update my JavaScript to reference that file. Let's see the result. can.View returns a document fragment. This is a lightweight collection of DOM elements that can be inserted into the document very quickly. They can be used with DOM methods like append child and insert before. They can also be used with jQuery's DOM modifiers like append, HTML, before, after, and replace with. can.View accepts deferreds. Deferreds are an object that will have a value at some point in the future. You can listen to when a deferred resolves with that value. Let's see how they work with a basic example. First, I create a deferred. Then I listen to when it's resolved. Finally, I resolve it with a value. can.View's ability to accept deferreds is handy because it's common to wait for multiple sources of data to load before updating the page. Model service methods return deferreds, making this pattern straightforward when using can.Model and can.View. Let's look at a brief example where I load two to-dos in parallel and render them to the screen. First, I'll register a favorites EJS template with can.View. Then I'll render it with the result of a find one of to-do 1 and a find one of to-do 2. When both to-do 1 and to-do 2 have been loaded, the template will be rendered into a document fragment. That document fragment is used to resolve the deferred returned by can.View. If you want to use partial or subtemplates, you don't want to render a document fragment and instead want a string. can.View render does exactly that. can.View render works just like can.View, except it returns a string instead of a document fragment. EJS is CanJS's default templating language and used with can.View. It provides live binding when used with observes. Live binding means that a rendered EJS template will automatically update itself when data in an observe changes. An EJS template looks just like HTML, but with magic tags where you want dynamic behavior. As we've seen with can.View, the following template renders to-do elements. Notice that this in the template is the list of to-dos. The data argument passed to can.View becomes this in EJS. can.View renders the template into a document fragment and inserts it into the page. This results in an li element for each to-do. Let's learn more about EJS's dynamic magic tags. Magic tags are special tags embedded in EJS that control how the template behaves. EJS has 5 types of magic tags. Let's go through each one. The control magic tag simply runs any JS code you have. You'll notice we've embedded a for loop in a control tag. As an example, I'll add a console log to output each to-do's name. The %equal magic tag inserts the escaped result of the code statement into the page. This means it will escape HTML characters. For example, I'll change a to-do's name to include some HTML. The %equal tag works just like %equal, except it does not escape HTML characters. For example, I'll change the template to use %equal. The %% magic tag is used if you want to write magic tags to the HTML content of your page. Notice how magic is printed instead of evaluated. The %pound magic tag is used to comment out magic tags. I can comment out a console log. EJS templates can automatically update their HTML when observed data changes. This is live binding. To enable live binding, use the attr method to read properties in EJS. When the property's value changes, EJS will update the DOM for you. To see it in action, I'll convert our template to use the attr method. You might think something like this would work. It doesn't. The reason is that EJS converts what's in the magic tag to a function. When the name changes, it calls that function. In that case, I will be 3, which is what I is after the for loop is done iterating. The fix is pretty simple. Just use an iterator like jQuery's. Now our live template is live, but to see it in action, I need to be able to change a to-do's name. For that to happen, I'll make our to-do's list accessible to the command line. Let's change the first to-do's name. Notice how the DOM is updated. Let's try adding a to-do to the list. It doesn't show up. We'll see how to fix that in the next section. This template doesn't update when items are added or removed because nothing is reading a property that changes when items are added or removed. We can fix this by reading the length property. A list length property changes whenever an item is added or removed. A list's each method will also use after to read the length property, so we can change our template to use each. Remember how model lists automatically remove destroyed instances? When we destroy an instance, it removes itself from the list, changing the length property and updating the DOM. EJS allows you to run code on an element after it has been created by returning a function within the %equal magic tags. Sometimes there are certain element properties that cannot be set in HTML. The most common case is setting model instance data on an element. In many apps, you want to know the model instance an element represents, so when someone does something to an element, you can look up the model instance and perform some action on the instance. The easiest way to do that is with the arrow syntax. Let's add to-do instance data to each LI. Now we can get a to-do instance from an element. Can control is used to organize controls with key value binding. It serves as both a traditional MVC view, creating UI widgets like tabs and grids, and a traditional MVC controller, organizing views and models into higher order business rules. Let's use control to build a to-dos widget that lists to-dos and lets us delete them. First, I'll extend can control with instance properties and overwrite its init method to load to-dos and draw them into the page. I'll create an instance of to-dos on the to-dos element. And update to-dos EJS with the destroy link for each to-do. Refreshing, you should see something like this. A control's init method is called when a new control instance is created. When you create a control, you can pass it a CSS selector, HTML element, or a node list, and optional options. The element is converted to a node list, a jQuery wrapped element, and the options are merged with the control's static defaults property, and they are both passed to init. Init is where a control's initialization code should go. The node list passed to init is often referred to as the control's element. By the way, when I say node list wrapped element, if you are using jQuery, I mean a jQuery wrapped element. See how element has jQuery's HTML method? This node list is set as the control's element property. Notice how I could change init to use this.element instead of element from the arguments. The options object passed as the second argument to a new control is merged with the control's static defaults property and set as this.options. We can use options to allow someone to specify the template to render. The static defaults property allows you to specify default option values. I can specify to-dos EJS as the default to-dos list template. Now we don't have to pass the view option to to-dos. Let's see to-dos past another template option. Similar to element, options is available on the control instance. Now, I want the to-dos widget to send a message anytime a to-do instance is selected. This selected event will be listened to by a traditional controller control later. We need to-dos to listen to clicks on li elements. Control makes this easy because it automatically binds prototype methods that look like event handlers. So I'll add a prototype method of the form selector space event name. In this case, li click. If I wanted to listen to anytime someone clicks on the to-dos control, I could just write click. The li click function will get called back with the node list wrapped element that was clicked on and the event. Control is using event delegation, so you can add li elements without needing to rebind event handlers. I'll make the event handler trigger a selected event with our model data. I can listen to selected and print the name of the selected to-do. I'll also listen to clicks on the destroy link and destroy the to-do instance. L in this case is the destroy link. To get the instance, I'll get the parent li and use jQuery data to retrieve the to-do instance. Finally, I'll destroy it. Oh, don't forget to call stop propagation, which prevents the li click method from getting called on something that's being destroyed. After refreshing, we can destroy to-dos. Similar to how you can template URLs in Model, you can template event handlers in Control. For example, we can make the destroy event configurable by replacing the event name with a template. When the control instance is created, it will replace destroy event with a value either on the options or on the window. Let's pass to-dos a destroy event option. Now, we're destroying to-dos on mouseover. Sometimes you'll want to configure these rules globally, especially when switching between desktop and mobile apps. So we could configure an events object that specifies destroy behavior and reference that in the control. Templated event handlers also let control bind on objects other than the control's element. These event handlers get cleaned up when a control is destroyed. This is really important because MVC apps are always listening to events on the model layer. But let's first see how it's useful just listening on other DOM elements and objects. To demonstrate, I'll make a basic tooltip that hides itself when someone clicks on the window. We can listen to window clicks with window click. Basically, if what's inside a template is an object, events are bound to that object rather than the control's element. Let's create a tooltip. Notice how, when I click on the window, the tooltip's listener is called and the tooltip is removed. This is really useful when listening to events on models. Let's create an editor control that updates the element's name when the input element is changed. When the editor is created, it calls setName. SetName sets the element's value to the name of the to-do passed to the editor as an option. When the input element's value changes, we update the to-do's name property with the element's value and save it to the server. Finally, if the to-do is destroyed while it's being edited, we'll remove the editor element, destroying the editor instance. Let's add an editor input element to the page. Get a model instance to edit, and create an editor control instance. Now if we destroy a to-do instance in the list, the editor automatically removes itself. Destroy unbinds a control's event handlers and releases its element. This is used to prevent memory leaks, but it does not remove the element from the page. Notice what happens if we destroy the to-dos control. When a control's element is removed from the page, destroy is called automatically. To see this, I'll create a basic window click count widget. I'll add window click count to an element. Notice how, when I click the window, it logs a message. After removing the element, the control is automatically destroyed, removing its event handler on the window so no message is logged. Basically, can control makes it almost impossible to write leaking code. On is used to rebind a control's event handlers or bind to objects or elements that can't be easily listened to with templated event binding. Instead of creating and destroying the editor widget each time we want to edit a to-do, I'll give the to-do editor a to-do method that will take a to-do instance to edit. I'll update the to-do option and call setName. And instead of removing the editor when a to-do is destroyed, I'll just hide it. But wait, we are changing which to-do we are listening to in the to-do method. We need to tell control to unbind the old to-do and bind on the new to-do. Fortunately, there's an easy way to do that, this .on. We'll show the editor when someone passes a new to-do. Finally, we'll add an editor input element. Create an editor on it, and update the editor when a to-do is selected from the list of to-dos. Let's see it in action. Route provides routing functionality. It's a special observe that updates the hash when its properties change and gets updated when the hash changes. Routing rules can be created that translate URLs into property values. But first, let's explore the behavior of can.Route before any routing rules are added. Notice how there is nothing in the hash and nothing in the route. If we change the hash, the route data reflects it. If we change the data, the hash reflects it. You can use attr just like observes attr. The can.Route method creates routing rules that match the hash and translate it into properties on can.Route. For example, I'll make a route that matches a hash that looks like word/word, where a word can be any character other than / or ampersand. When the hash matches this rule, it adds a type and ID property to the route's data. If we change the data, can.Route will run its matching rules in reverse, selecting the best rule for the route's data and setting the hash accordingly. can.Route's default argument provides additional or default properties to set on can.Route when the rule is matched. So if I wanted to do 3 to be the default data we show, I could match the empty hash and provide default values of type to-do and ID 3 to can.Route's data. Now if I navigate to the empty hash, default data is set. Just like observe, you can listen to changes in route data with bind. For example, I'll listen and log when the ID is changed. I can change the ID with the attr method, or changing the hash. You can also listen to these events with can.Control. I can create a router control that logs when the route's ID changes. can.Control supports special route events. These events let you create a routing rule and listen to when it's matched, all in one step. This is great for apps with simple routing rules like this one. I will create a routing control that will listen for the empty hash and for routes matching to-do's ID. When the empty hash is matched, I'll hide the editor's element. When to-do's ID is matched, I'll get the to-do by ID from the model and update the editor with it. When an LI is selected, I'll update can.Route's data ID, creating a hash change that will update the editor. Finally, I'll create the routing control on an element that contains both the to-do's list and the editor. In this case, I'll put it on the body element. Now, we are able to select to-dos to edit and toggle through our selections with the back button. And we can still destroy to-dos. As our routing control is a traditional MVC controller, I'll have it create the traditional MVC views it operates on, to-dos and editor, and update the code to reflect this. And there you go, a working, history-enabled to-do editor. There's only two more things you should know about can.Route. can.Route URL takes route data and using the routing rules returns a hash. Let's make a URL for to-dos 2 and set that URL as the hash. Link works just like can.Route URL, except it returns the HTML for a link. We can make the HTML for a link to to-do 3. Insert it into the page and click on it.